Hello, everyone. My name is Hannah Olana. I will be presenting Data 670 Data Analytics Capstone project here at UMGC on predicting gestational diabetes mellitus. Thank you, Professor Salib, for the opportunity. I will start with the executive summary. This project uses predictive modeling to identify factors which contributing to gestational diabetes mellitus (GDM). The analysis integrate the diabetes health indicator dataset in the GDM dataset to provide insights into health, lifestyle, and clinical factors affecting GDM risk. Machine learning techniques like logistic regression, random forest, and gradient boosting will be used for early detection to improve maternal and neonatal health outcomes. Gestational diabetes mellitus (GDM) is a condition of high blood sugar level during pregnancy, which can affect the health of both mother and baby. It occurs when the body cannot produce enough insulin to handle increased glucose levels. Early detection through predictive analytics can enable proactive intervention that reduce adverse maternal and neonatal outcomes. The overall project scope, GDM is a significant maternal health concern affecting 10 to 15% of pregnancies worldwide. Late stage detection increases risk for both mother and child, leading to long-term complications. This project applies predictive analytics to identify high-risk individuals for early and informed targeted interventions. Why important of early prediction? So the traditional GDM screening, which usually typically screen using the oral glucose tolerance test, which is administered between 24 and 28 weeks of pregnancy. This test involves like drinking a sugar solution and measuring a blood glucose level at a specific interval to assess how the body processes sugar. However, this timing considered late in the pregnancy because it's already like 28 weeks. At this point, some complications associated with GDM may have already begun to develop. So, early detection could allow healthcare professionals to implement preventive measures sooner, like recommending dietary change, physical activity, or insulin therapy whenever necessary. So, the business understanding, this project falls within the maternal healthcare and focuses on using predictive analytics to forecast GDM risks. Early intervention can reduce complications like high birth weight, premature delivery, and type 2 diabetes. The study, along with the healthcare sector, they shift just from reactive to preventive care. So, predictive model help healthcare professionals tailor to treatment plan based on individual risk factors like BMI, glucose levels, and age. The main objective is to provide clinicians with an early warning system to guide interventions. This proactive approach improves health outcomes, reduce cost, and support better resource allocation within the healthcare systems. The organization and stakeholders is number one, pregnant women, which is direct beneficiaries through improved prenatal care. Next, healthcare professional use model insight for clinical decisions instead of just traditional like OGTT method. Hospital and clinics, they optimize resource by identifying high-risk patients early. Public health officers, they can inform policy decisions and maternal health initiatives. Another insurance company, which they can cost savings through reduced complication rates. So, saying this, the dataset description, I will use two datasets. One from diabetes health indicator dataset from Kaggle, which have 236,378 rows and 22 features, which contain data on BMI, physical activity, cholesterol level, lifestyle factors. The second diabetes dataset is from Gestational Diabetes Mellitus dataset from Fixture, which have 23,491 rows and 48 features, which include pregnancy-specific data such as glucose tolerance test result and gestational weight gain. The data sets are integrated to provide holistic understanding of metabolic and pregnancy-specific risk factors. Now, the slide about data preparation. The data preparation process involves the following steps. The first steps is data cleaning, handling missing values and correcting inconsistent record. Second, data transformation, which involve creating new features like insulin resistance indices for better predictions. Third, feature engineering, selecting the most relevant predictor for GDM risk. The fourth is data integration, which I will merge the Kaggle and the Figshare dataset while aligning variable definitions. This is the high-level data flow diagram, which use the post dataset from diabetes health indicator datasets in gestational diabetes, and then which involve data pre-processing, cleaning, feature engineering, and handling missing values, and merge the dataset to integrate GDM and metabolic risk factors, and then predictive modeling, which I will use random forest, gradient boosting, logistic regression, then clinical application, decision support for GDM risk factors, which using the predictive insight for decision support. Data cleansing and transformation. So this phase, as I mentioned earlier, when data cleansing, removing duplicate record and putting missing values median for continuous variable and mode for categorical variable, and normalizing numeric features for comparability, encoding categorical variable using one-hot encoding, properly clean data enhance model accuracy and reliability. Then data transformation, so which is feature derivation, so creating a new indicator like insulin resistance indices, feature scaling, applying min-max scalar for consistent glucose and BMI and other clinical measurements, class balancing using small to address the underrepresentation of GDM cases, sorry. This process prepared the dataset for efficient and accurate machine learning modeling. So this step about key performance indicator, KPI, which model accuracy evaluate using precision, recall, F1 score, and AUC. Reduction in late diagnosis, which measure impact by comparing traditional versus predictive model detection timelines. Clinical adoption, assess how interpretable and usable the model is for healthcare professionals. Cost effectiveness, evaluate potential saving from reduced emergency interventions. Dataset justification integration, as I said earlier, the Kaggle dataset provide broad diabetes risk factors, while the Figshare dataset includes pregnancy-specific details. Combining this dataset ensure a holistic risk assessment approach. Data pre-processing involve merging, normalizing, and handling missing value, and applying feature engineering. This time, exploratory data analysis, EDA. EDA identified trend in relationships, correlation analysis to find key predictors, distribution plot to visualize glucose level across risk groups, I'll use heat map to explore variable relationship, backsplat to detect outlier like unusual high BMI. So just with this, EDA provide the insight into which features are most relevant for predicting GDM. Predictive modeling techniques, which I will use logistic regression. It provides interpretability for clinical use. Random forest capture nonlinear relationship between features. Another one is gradient boosting, which optimized for handling imbalanced data set and improving predictive accuracy. The model conversion based on precision, recall, F1 score, and AUC. Expected results and impact. Identifying early warning sign of GDM through predictive analytics, providing healthcare professionals with decision support tools, reducing healthcare costs by preventing emergency intervention, enhancing maternal and neonatal health outcomes through early interventions. So this time, what will be the challenge? And what will be the solution for the challenge? First, data imbalance. So there will be expected data imbalance because addressing two different data sets. So I will try to address using mod synthetic minority oversampling technique, feature selection, applied recursive feature elimination with RFE for optimal predictor identification, interpretability, ensure model outputs are easy for healthcare providers to understand and use. The next step uh, will be I will wait and then gather peer feedback on my approaches and then refining feature selection and hypermeter tuning. And then I will develop visualization dashboard for easier model interpretation and clinical adoption. I have used the following references. Thank you so much for your help. Thank you for listening. Thank you.